Kak, cek cek. Cek cek. Boleh nih? Yang satu di podium ya? Boleh podium. Rekaman dah. Oh, ya. You invite them. Yes, well, I will. Yeah. After. Shall we begin? Assalamualaikum warahmatullahi wabarakatuh, and very good morning, ladies and gentlemen, distinguished guests, honorable speakers, and all participants joining us in person here at the Ruang Sidang of Faculty of Marine Science and Fisheries Hasanuddin University, and also joining us virtually via Zoom. Welcome to the Talent Cultivation and Technical Personnel Training course on China, Indonesia Marine Ranching Technology. This prestigious event is collaboratively brought to you by Hasanuddin University, Shanghai Ocean University, and Guangdong Ocean University. And this event is organized by the Faculty of Marine Science and Fisheries, Hasanuddin University. Before we begin, I would like to invite our honorable speakers today. I would like to invite to joining us at stage the Dean of Faculty of Marine Science and Fisheries. On this occasion is represented by the Vice Dean for Partnership, Research, Innovation, and Alumni, Professor Dr. Mukti Zainuddin MSc, to joining us at the stage. And I would like to invite the Vice President of Shanghai Ocean University, Professor Wei Jini, to joining us at stage as well. And lastly, I would like to invite the Rector of Hasanuddin University, that on this occasion is represented by the Director of Partnership of Hasanuddin University, Bapak Ansariadi, MSc, PhD. Okay, ladies and gentlemen, shall we begin to our next agenda? We would like to invite the Dean of Faculty of Marine Science and Fisheries of Hasanuddin University. In this case, on this occasion, is represented by Professor Dr. Mukti Zainuddin, who is the Vice Dean of the Partnership, Research, Innovation, and Alumni. To the Vice Dean, to Professor Dr. Mukti Zainuddin, to deliver your welcoming remarks. Thank you.
Okay, thank you, Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Distinguished Vice President of Shanghai Ocean University, Honorable lecturer, researcher, and student from Shanghai Ocean University and Guangdong Ocean University. Respective Vice Dean, lecturer, and college and student from Faculty of Marine Science and Fisheries, Hasanuddin University. Ladies and gentlemen, On the behalf of Faculty of Marine Science and Fisheries, Hasanuddin University, it's a great pleasure to welcome all of you to the China-Indonesia Marine Ranging Technology, Thailand Cultivation and Technical Personal Training Skill. We are deeply honored to host this important event in collaboration with the esteemed partners Shanghai Ocean University and Guangdong Ocean University. This workshop reflects the strong and growing partnership between our institution in advancing marine science, fisheries innovation, and sustainable ocean development. I feel today's program provides a valuable opportunity for researchers, lecturers, and students, and professionals from both China and Indonesia to exchange knowledge, share experiences, and explore the latest development in marine ranging technology. We believe that through collaboration and mutual learning, we can contribute to sustainable management, utilization of marine resources for the benefit in our countries and the wider global community. In this wonderful opportunity, we would like to express our sincere appreciation to the Vice Presidents of Shanghai Ocean University, as well as all researchers, lecturers, and students from Shanghai Ocean University and Guangdong Ocean University for joining us today. Your presence demonstrates a shared commitment to academic excellence, innovation, and international cooperation. We hope that this training course will be productive, inspiring, and enjoyable for all participants, and it will be further strengthen the friendship and collaboration among our institution. Thank you once again for your participation. We wish you successful and fruitful workshop. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you to the Honorable Vice Dean for Partnership, Research Innovation and Alumni. Next, we shall hear the remarks from our partner in China, partner university in China. We would like to welcome the Vice President of Shanghai Ocean University, Prof. Wei Jini, to deliver his address.
尊敬的哈萨努丁大学的各位同仁，来自印尼渔业界的各位代表，以及现场的同学们，大家上午好。
Distinguished colleagues from Hasanuddin University, representatives from Indonesia's fisheries community, and also dear fellow participants, good morning.
非常荣幸能够在风光旖旎的望嘉溪，与各位共同出席此次的技术培训会的开幕式。今天，来自上海海洋大学与广东海洋大学的专家团队，将与印尼的同仁们齐聚一堂，围绕全球渔业发展与渔业管理，以及人工鱼礁建设效果调查与评估两大主题进行深入的交流和探讨。在此，我谨代表上海海洋大学，对本次培训会的顺利召开表示热烈的祝贺，向精心筹备此次活动的哈萨努丁大学海洋与渔业学院的各位同仁表示衷心的感谢，向冒着酷暑前来参加培训的学员致以诚挚的问候与热烈的欢迎。
It is a great honor to join you here in the beautiful city of Makassar for the opening ceremony of this technical training workshop. Today, expert teams from Shanghai Ocean University and Guangdong Ocean University will gather together with our Indonesia colleagues for in-depth exchanges and discussions on two major themes, that is global fisheries development and fisheries management, and also the survey and assessment of artificial reef construction effects. On behalf of Shanghai Ocean University, I would like to extend our warm congratulations on the successful opening of this workshop, express our sincere gratitude to our colleagues from the Faculty of Marine Science and Fisheries at Hasanuddin University for your very great arrangement, and offer my cordial greetings and a warm welcome to all the Indonesia trainees who have made all the way to be here with us.
中国有句古话，授人以鱼不如授人以渔。在我看来，今天我们在这里举办这场培训会，正是对这句话最好的实践。它存在的意义远远超出了技术传授的这个本身。
As an old Chinese saying goes, it is better to educate a man to fish than to give him a fish. To me, this training workshop we are holding today is precisely the best practice of that philosophy. That is, its meaning reaches much further than just passing on technical knowledge.
当前，全球渔业资源正面临着气候波动与过度开发的严峻挑战。如何进行科学有效的管理，是我们中印尼两国乃至全世界共同面临的课题。过去几年，我们与哈萨鲁丁大学在亚洲合作资金项目中印尼近海海洋生态牧场技术合作研究并肩奋斗，取得了令双方都深感自豪的阶段性成果。我们在邦内坦蓬岛的海域投放的人工鱼礁已经焕发出勃勃生机，珊瑚在生长，鱼群在聚集。这些实践成果证明，科学技术是推动海洋渔业可持续发展的核心动力。
Currently, global fishery resources are encountering severe challenges from climate change and overexploitation. How to achieve scientific and effective management is a common challenge faced not only by China and Indonesia, but by the entire world. Over the past few years, we have worked side by side with Hasanuddin University under the Asia Cooperation Fund project, China-Indonesia Offshore Marine Ecological Ranching Technology Cooperation Research, and have achieved interim results that both sides are proud of. The artificial reefs we deployed in the waters of Bonatembo Island have now come to life. Corals are growing and the fish are aggregating. These practical outcomes demonstrate that science and technology are the core driving forces for sustainable marine fisheries development.
如何将这些技术和经验普及开来、传承下去，正是我们今天在此相聚的目的。本次培训会是我们践行技术创新、人才培养、技术推广一体化合作模式的关键一步。在接下来的半天时间里，来自2所中国高校的专家们将毫无保留地分享他们在全球渔业治理、渔业资源科学养护以及人工鱼礁精准监测等领域的前沿知识和实践经验。我们希望通过今天的培训，能够让在座各位深入了解全球渔业发展的最新趋势和管理策略，同时也能够掌握一套科学、实用的人工鱼礁效果调查与评估方法。
How to disseminate and pass on these technologies and experiences is precisely the purpose of our gathering here today. This training workshop is a critical step in our implementation of an integrated cooperation model that combines technological innovation plus the talent cultivation plus the technology extension. Over the next half day, experts from the 2 Chinese universities will share unreservedly their cutting-edge knowledge and practical experience in areas such as global fisheries governance, scientific conservation of fisheries resources, and the precise monitoring of artificial reefs. We hope that through this training, all of you here will gain an in-depth understanding of the latest trends and the management strategies in global fisheries development, and at the same time acquire a scientific and a practical set of methods for surveying and assessing artificial reef effects.
更重要的是，我们期待这次培训能够成为一个多方对话的平台，让来自高校的学者、政府部门的管理者、产业界的从业者以及长期生活在海边的岛民朋友们能够坐在一起，相互倾听，相互启发。毕竟，海洋生态的保护与渔业的发展离不开每一位参与者的智慧和努力。
More importantly, we hope this training can serve as a platform for multi-stakeholder dialogue, bringing together scholars from universities, managers from government agencies, practitioners from the industry, and friends from local island communities to sit together, listen to one another, and inspire one another. After all, the protection of marine ecosystems and the development of fisheries cannot succeed without the wisdom and efforts of every participant.
最后，衷心祝愿本次培训会取得圆满成功，祝各位学员学有所获，满载而归。让我们携手并肩，为印尼海洋渔业的可持续发展，为中印尼海洋合作的更加美好的明天而努力奋斗。谢谢大家。
Finally, I sincerely wish this training workshop a complete success, and I hope that every trainee will gain valuable knowledge. Let us join hands and work together for the sustainable development of Indonesia's marine fishes and for an even brighter future of China-Indonesia marine cooperation. Thank you. Thank you very much.
Thank you very much for the Vice President of Shanghai Oceanic University for the wonderful remarks. Ladies and gentlemen, now we come to the official opening of today's training course. The remarks and the official opening will be delivered by the Rector of Hasanuddin University, who is represented by the Director of Partnership of Hasanuddin University, to Bapak Ansariadi, MSc PhD. Please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Our honorable guest, Vice Rector from Shanghai Ocean University, Professor Wiji Ni. Welcome and thank you very much for visiting Makassar. We really appreciate. I know you are quite busy probably in China, but you are willing to spare your time to join with us today in a very important event in terms of marine Indonesia marine ranching technology. And also, welcome to our colleague from Guangdong Ocean University, Professor Wang. I met him many times. We're discussing many issues. And also, I would like to welcome Professor Lili Zhu. Thank you very much again for visiting us here. I really apologize for some of the rector, and I know the Dean of Marine Science are gathering today in also another important event that is graduation day, and that's why Rector and the Dean were unable to join with us. But I would like to say again, thank you very much for all the speakers and all the leaders from three different universities, Shanghai Ocean University, Guangdong Ocean University, and Hasanuddin University. I know that you're already long outstanding collaboration, and as a director of partnership, I have seen the collaboration among these three universities quite intensive. And if I would say this is probably one of the most intensive collaboration between UNHAS and Overseas University. I saw the intensive visits from Shanghai Ocean University. I saw the intensive visit from Guangdong Ocean University. I've seen the research collaboration that had been conducted. And most importantly, these universities also involving students. And I really like your quote, Professor Liliso, that it's really much better to educate about fish instead of giving fish. So what I'm doing today is that we are trying to educate young students, probably from undergraduate, but probably also from master degree, in some of the most important issues in fishery, like what we've seen here, that's international fishery development management, integrated acoustic optical underwater surface. So these two skills, of course, are important in terms of marine technology and fisheries technology here in Indonesia. So I really like that students who are joining us today will be able to gain some benefits from this training. I know there must be some barrier in terms of languages, but we have technology. You can use your mobile phone if you want to communicate your colleagues from China. I also try to understand some of the Chinese language, enable both of us to be able to communicate effectively. But again, try to do some interaction among students, and also gain some skills from our college from these two universities, Guangdong Ocean University and Shanghai Ocean University. I really hope that this training, one day trainings, will provide insightful and benefits for both, for three universities here. UNHAS for Marine Science, Guangdong Oceans, and Shanghai Ocean. I also hope that Guangdong Oceans and Shanghai Ocean University are able to accept more students from here, either from master degree and PhD degree. I know there is one or two students already from here will conduct their study in Shanghai Ocean University, and this is really important in terms of nurturing future researchers, future scientists in marine sciences. And I really hope, then I request if you could get some more masters and PhDs from UNHAS, we will really appreciate. So again, thank you very much for hosting this training. And also from Guangdong Ocean and then Shanghai Ocean, I really appreciate your willingness to travel far away from China to Makassar. And I really hope, because China and Indonesia, you're only separated by ocean. So, but we really hope that ocean not separating us, but as a bridge for us to connecting between China through South China Sea, between Indonesia and Shanghai. You can actually travel by boat from Indonesia to Shanghai, and that's really important to unite us. So on behalf of Rector Hasanuddin University, I officially opening training today by reciting Bismillahirrahmanirrahim. Thank you.
Thank you very much to the Director of Partnership of Hasanuddin University for officially opening our event today. Now we are moving to photo group session. We would like to invite to all our international colleagues and our Vice Dean, Vice Director and Vice President of Shanghai University to stand in the front, please. And our international colleague to join us here. September. Photographer ready? Oh ya? Sampai aku aja. Oke. Oh, enggak sampai. Prof Yusri, tablet Prof. Bisa di sebelah sana, Prof. Okay, in the count of 3, 1, 2, 3. Okay, thank you very much. Please give a round of applause to bring a good spirit to begin our event today. Now we have 5 minutes for a quick break, and we will see you in 5 minutes in this aula. Thank you. Oh, ini muna. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, ladies and gentlemen. Now we are entering the core session of our event today. We are very fortunate to have three extraordinary speakers for today, and I would like to welcome welcome into to the stage. Our first speaker is Dr. Shi Kwao from Shanghai Ocean University. Our second speaker is Dr. Ning Chen from Guangdong Ocean University. And last but not least is Xu Xiejiang from Shanghai Ocean University. I hope I did spell your name correctly, okay? Please, okay. And for the first speaker, we have Dr. Shi Kekao from Shanghai Ocean University. But before we start his presentation, I would like to read his short biography. Dr. Shi Kekao received his PhD degree in agriculture from Shanghai Ocean University in June 2023 and is currently a teacher at the Shanghai Ocean University. He also serves an international visiting researcher at the Atmosphere and Ocean Research Institute, the University of Tokyo. His research focuses on marine ranching and habitat connectivity with particular interest in the conservation and sustainable development of marine ecological resources. He has published more than 30 sci papers, co-authored 2 academic books, and obtained 3 national patents. He also received several honors, including the 2023 Bogang Excellent Student Awards and the Shanghai Super Postdoctoral Incentive Program. Wow. Please give a round of applause for our first speaker. Do we have the slides? Okay.
I should be here. Yeah.
Whenever you're convenient.
Okay, here, just here.
Okay.
Okay. So, selamat pagi. Suatu kehormatan besar bagi saya untuk menyampaikan laporan ini. Hai. So, it's my great pleasure and honorable honor to be here to give my presentation to all the audience for today. So this is my first time in Indonesia, and actually previously I present online for twice in 2023 and 2024. So this is my first time on site, so I feel really excited to see you guys here. So today I'm going to share an interesting topic about the artificial reef monitoring and evaluation. So, I'm sorry. Okay. So I'm going to introduce the topic from the 4 aspects. From the first one is I'm going to show you some terms. It seems like it doesn't work. I'm sorry. Yeah. Okay. Okay. So, do you know what artificial reef is? So, the artificial reef is a man-made structure intentionally deployed on the seabed. So, its purpose is to increase the habitat as well as its configuration and even the enhancement of fishery resources. There's a lot of functions I'm going to show you later. And we've got 2 surveys. The main survey, the first one is the baseline survey, and the second one is a follow-up survey, which is very important to our investigation. So the follow-up survey is the one we want to construct artificial reef and deploy the artificial reef in this targeted sea area in the first place, and then we will go to the follow-up survey to evaluate the artificial reef construction effectiveness. Okay, so we've got 2 main functional areas. So first one is the called functional area, and the second one is reference area. So they have 2 different meanings, different definitions, or I'm going to show you later. Okay. Okay. Maybe the distance is a little bit long.
I think because of the distance.
Yeah, distance.
Kayaknya karena kejauhan yang
Okay, next. Next, please. Next, please. Okay, and the first aspect I'm going to show you how we monitor the environment and as well as the water quality and the sediment. Okay, next. So this survey includes a lot of indicators we want to collect during the investigation, including marine hydrology, water quality, sediment, and topography, and some as well as the plankton community structure. Okay, next. Yeah, so the annual survey will be like conduct monthly or quarterly per year, and this survey should be consistent with the hydrodynamic survey. So here you can see from the subsection I showed in hydrological survey, there will be like a lot of indicators we want to collect, including the depth, temperature, salinity, and transparency, even the velocity and the direction. Okay, so for the frequency, we usually conduct once monthly and quarterly per year, and we will set up a target area called artificial reef area in the center, and around which we will set up a lot of reference areas. Okay, next please. So, okay, it's okay. So this is a specific tool to measure the salinity and transparency using this camera called salinity meter and such a disk. Okay, next please. And the second one is the water quality survey. So what is that? So you know the topography, the seafloor is really complicated. So in that way, we should know the water depth in the first place. So when the depth is less than 10 meters, we will collect just the surface water samples. When the water is more than or equals to 10 meters, we will like to consider both surface and bottom samples. Okay, so this is tools we are going to use in the actual sea areas. Backward. Okay, this one is called pH meter and dissolved oxygen. A lot of indicators we would like to measure using specific tools. Yes, including the water samplers shown in that picture. Okay, next. Yeah, so for the station design and the frequency is all the same. We just set up one artificial reef site in the center, and around we set up several references areas. Yes. Okay, next one. So for the analytical methods, I'd like to show you some main items, including the physical parameters and some water samples that we will analyze we will send back to the water sample to the laboratory for further analysis, like the nutrients and even heavy metals, right? So we use different analytical methods here. So I'm not going to show you in details. So please just have a quick look about it. Okay, next. Yes, these are the main tools we're going to use. An instrument called a such disk is used to measure the transparency, and even the field, a lot of water quality analyzer, and even the water sample being sent back to the laboratory for further analysis, like nutrients, using the light spectral photometer. Yes, this is very complicated and interesting. If you are interested in, I'm going to show you after discussion. Okay, next. Okay, after introducing the... Yeah, thank you. After introduction of the water quality survey, I'm going to show you how we conduct a survey about the seafloor topography and the geomorphology survey. Okay, so it's a little bit different because I myself is not familiar with this one, but I know is that we installed antennas on the vessels, and then we will launch the signals and receive the signal back, and then we will get all the information about the sea floor, and when we get the data set, we would like to analyze it in the deeper analysis and try to plot the map. If we got the comprehensive map, we will get a holistic perspective of all the actual sea area and the sea floor. That is very interesting. It's about the physical oceanography, but which is not my major. I'm sorry about that. So next one. Okay. So according to the map we designed, we are going to do the next survey. Yeah, which means we can know all the information in the next, maybe the follow-up surveys. Yes, okay, next. Yeah, for the frequency, it's almost the same. It should be consistent with the water hydrological survey. Okay, next. Okay, in this survey, I'm going to introduce the sediment survey. Do you know the sediment? I think it's very easy to understand, right? Yeah, so for the sediment survey, we just collect, we should consider both the core sediment, the vertical one, and the surface sediment of 5 to 10 centimeters. Yes, okay, next. Yes, okay, yeah, it's enough, yeah. It's okay. So design is all the same, should be consistent with a hydrological survey. And next, please. Okay. Yes, as I mentioned, we should consider both the vertical and horizontal surveys of sediment. We try to collect both of them and try to analyze it. And next, please. Next. So I'm going to show you some indicators we like to determine in the laboratory. Is it work? Oh, thank you very much. So yes, for the surface sediment, we just collect we just measure some heavy metals and even the benthos community structure that I will introduce later, and using some specific method here, but I think the font is a little bit small, but so please just have a look about this. Yes, okay. The next one is the plankton survey. Yes, we're using the plankton type 1 and type 3, which is commonly used during the investigation. Yes. So we have two types of trawling. Like the first one is vertically. We will trawl the line vertically, and then the horizontally drag the plankton net and try to collect. I think the duration time will like 10 to half minutes. 30 minutes. Yeah, using the plankton survey. And of course, we will use the type 3 plankton net to collect the fish egg and the larval fish. This is sometimes the results are invalid because they would like less fish egg and larval we got. But we will try to our best to try to take more time using the plankton net to get more samples. And of course, during in the tidal zone, we would like to use a specific tool called quadrot. You know quadrot, like to collect the sample, bentho samples, yes? Yeah, so yesterday I went to the islands and found a lot of things. The local fishermen, they use the dive into the water and then collect using, I'm not sure what kind of methods they use, but they just show me a lot of sea star and live coral reefs. Yes, I think they use the quadrot. I'm not sure about that. So usually during our survey, we will use the quadrot to collect, consider regarding the microalgae and the benthos. Yeah. Okay, these are the analytical methods I showed in this table. Yes, including chlorophyll, plankton, and lava fish as well. even the nectar. So I'm going to show you the next section about the fishery resources survey will include all of this. Okay. Okay, here we can the fishery resources survey. So this survey focuses on the fishery relevant biological resources associated with artificial reef areas. Yes, particularly the fish assemblages and nectar and the reef associated organisms, community structure. So as you can see from this slide, I show you some vivid pictures showing different types of gears. The first one is the trawl, where we usually use during the investigation, and we also use the gear and the shrimp trap and even the crab trap. But these gears are not environment friendly, so we are going to use another measurement, another collecting methods to try to supplement the environmental friendly investigation. Okay, so this is what I mean. So this is under video camera survey. So sometimes we will have some professional experts of divers dive into the deep water around the rocky, all types of rocky reef or the coral reefs, yes, and try to observe the species composition and try to get the record and send it back to the laboratory for the video identification and try to count the number of species as well as its abundance, right? So it's really, the procedures are very interesting to go. Okay, so for the protocols following by, you can see that in details. I'm not going to introduce the details. Okay, so as well as the underwater camera survey, we have another one, which is a new technology appeared in the recent years, which is called environmental DNA technology. So this technology is used to test, is used to identify the fish species, competition, and the community structure. And finally, we will consider the diversity and try to describe the whole food web for the ecosystem, target ecosystem. So for the environmental DNA technology, we have two types of it. And the first one is the active sampling. So what is that? So which means we should use a target net called a plankton net to collect water samples. Just by collecting water samples and try to filter on the filter membrane, and then we will try to send the sample back to the laboratory, and for the sequencing and extract the information, DNA information according to the PCR barcoding, and then we'll know the information, all the information about the species existing in the actual sea areas. So this is called active sampling. Okay, for the next one, which is cutting edge and new technology happened within 10 years. So this is a passive sampling, which means we don't need to put the filter back to the laboratory. I'm sorry. We don't need to put the membrane on the plankton net. We just fix the edge membrane for the equipment like the grill here. And through the water go through the membrane, we will gather the DNA information automatically, and then we will just use the filter membrane for further analysis when the sample sent to the laboratory. So it's very convenient and easy way to know about the diversity of species in the ecosystem. So in next one, I'm going to show you brand new designed sampler in our lab. This is a design from our lab. So there are two main components consisting of this of it. The first one is the plankton net. Cause it's very complicated and difficult to design a new one, so we just designed it and modified it according using the existing plankton net. So for this one, all you just know is the main component is the gathering component. So this is our own design. We try to extract all the filter membrane, so water flow will go into the filter, and the membrane will automatically absorb all the materials, and then we can directly use the membrane and send it to the laboratory for further analysis. Okay, very interesting, right? So this is our entity design for the passive sampler for DNA information. So please play the video for everyone, please. Yes, we should submerge the DNA and the whole sampler below the surface water of 5 to around 50 centimeters. So it's try to get all the information about the species, DNA species. Yeah. So the duration time like 10 to 30 minutes. Yes, I think. And we've already applied for the patent successfully. Yes. And this is one of the dissertation finished by the students in our lab. He's very excellent. Yeah. Okay. Additionally, we will conduct other surveys like this one. Yes, we try to we try to look for the new way to evaluate the construction effectiveness of artificial reef. So in that way, we should consider the microorganisms and the folding organisms. So as you can see, I used the AI ChatGPT to generate the pictures here. So you can see the before and after. Maybe the first year when the artificial reef deployed on the seabed, there will be like less microorganisms on the surface. However, after a lot of years passing by, there were like a lot of microorganisms attached on the surface of the artificial reefs. So in that way, we can scrape some of the materials, subtract on the surface of the artificial reefs, and then try to get the analysis in the laboratory. So for the folding organisms, the collection is all the same, procedure is the same. Yeah. So in the next one, I'm going to show you how we collect the samples. How did it work? Yeah, we will have the professional expert diving into the deeper water and reach the artificial reefs and try to scrape the surface substrate of artificial reefs and send the samples back to the laboratory. And because the microorganism is very difficult to be identified, so maybe we should know the 18S RNA by sequencing. We need some specific methods and technology to identify the microorganisms. But for the folding organisms, it's very easy to access. So we just collect the samples around the artificial reefs and try to identify them by our own eyes. So it's very easy to get access. Okay. So in our laboratory, we also conduct the microplastic survey. However, we couldn't catch the fish along the coastal water of Indonesia. So we just consider the water and the sediment. So using these tools, this equipment, as I showed in the picture, the first one we use the plankton net, type 1, I think, to collect the water, surface water samples, as well as the bottom water samples. And then we try to use the marked sampler to collect the surface sediment for microplastic analysis. So as you know, the microplastic is a brand new pollutant as it has many multi-dimensional characteristics. So like in the daily life, we just everyone just breathe from the air, breathe the microplastics from the air. So even you drink water, you use the spoon and forks utensils, you will eat microplastics. So it's relevant to our daily life. It's very important. Yeah. So this is why we should conduct the microplastic survey during the investigation. Yeah, this is some methods to identify the microplastics from water and sediment. Okay, maybe this one, I'm not familiar with this one, but we have some student, we have just one PhD candidate doing this carbon sequestration in our lab. Only did I know, we just collect the samples like a macroalgae because you know these kind of things, the seagrass will absorb the carbon and storage into their body, and then try to analyze the origin and the source of the carbon in their body is a way to fix the climate change. Maybe this is the main key point that I want to explore in the future. So this is why we conduct the carbon sequestration survey. Okay, so for the last one is the social economic survey. So in this way, this is a long-term serious survey. So in that way, like we did yesterday, we went to the islands and talked to the fishermen using different questionnaires, like the first one called structured questionnaires. We just record some information according to the inquiry to the fishermen, and then we will directly go to the bureau or the relevant staff in the government and try to ask them some information about how artificial reef construction is good or not. Yes, this is called non-structured questionnaires because nowadays we lack of data set, so it's very difficult for us to do the data analysis. So in that case, we should collect more data set from the sea area using the questionnaires. So this is what I mean, it's a long-term shift. And we also go to the fishing market and some other places like a company or the entrepreneur for the field interview. Yes, which is similar to the previous two investigations, socio-economic survey. Okay, after introducing all the surveys, so I'm going to introduce you some assessment to explore the ecological benefit of construction of artificial reefs. Yeah. So this is a hydrodynamic assessment, which includes a lot of interesting things we should do. Like we should consider the wave in the tidal and the current velocity and direction, and try to combine them and analyze this in using a laptop, maybe the server, to try to map the try to do the mapping work. And then we should consider it like a temporal and spatial perspective of these things. The first one is we can compare the time series variation for the construction effectiveness of artificial reefs, and then we can know about the difference or similarity of species, composition, and community structure in the target area called artificial reef area, and around area called a reference area. Yeah, so this is very interesting work to do. And for the next following contents, we will like include a lot of tables. I'm not going to I'm not gonna go into details, so please just have a quick look about it. And the second one, the water quality assessment. Yeah, so I list a lot of items including the pH and nutrients and heavy metals, and we have different classifications and different descriptions about it. So the next we have the current status assessment called. We use a lot of formulas like the single factor assessment methods like the formula listed in this table. So please just have a look about it. I'm not going to explain too much about it. And we also use the comprehensive water quality index. According to the previous formula, this is much more complex. And then the result will include the classification and the description. For example, the class 1 from the result represents the clean status of sea condition, sea area condition, and while the class 5 represents the polluted severe pollution of the sea area. Okay, and we also use the formula here called eutrophication index. Yes, it's a comprehensive formula, consists of the previous two formulas. So it's also used to tell us the classification of the sea area and description here. So please just have a look. And we also have the temporal and spatial variation assessment. Yeah. So this is about the follow-up survey and basement survey. So the formula will be like the same. Formula is very simple to get access. So all you need to know is the classification here and the description, like a very poor, moderate, or very good seawater condition. And after finishing introducing the water quality assessment, I'm going to show you the sediment one. So it's all the same. Yeah, we have to measure the heavy metals, like maybe the total nitrogen, total phosphorus in the sediment. Yes, using the classification here and the description. And for the temporal and the spatial comparison, assessment, we have followed a lot of indicators and environmental parameters that recorded in the sediment during the follow-up survey and baseline survey, and we should also consider the functional and the reference area, and this one can tell us the sea condition of the sea area, whether it's healthy or not. And for this one, the biological assessment is a little bit complicated and different from the previous water quality and sediment. Yes, because we will consider much more complex indicators like the fish, plankton, including necton, and especially the migratory species or sedentary species. Yes, they would like much more information. I'm not going to go into details. So just remember, we have to calculate a lot of formulas like I showed here, the Dollmann's IRI or the diversity index. Yes, even the primary production I listed in this table. So just forget about the formulas here. Just all you should know is that we just conduct the current status, and for the next one is using a lot of formulas to identify the species composition and the community structure. And as well, we also have the spatial and the temporal assessment for each section. Yeah, like this one, using a certain formula here, right? Okay. So all in all, I'm going to take a review of you, just make a summary of it. So the first one is the hydrodynamic assessment, and then we will go to the water quality assessment, and then we'll go to the sediment assessment, and finally we'll go to the fishery resources assessment. And in the last one, I'm going to introduce the social economic evaluation after the fishery resources assessment. Yeah, this one. So for this section, we have a social economic benefit evaluation. It includes 3 parts. The first one is the direct benefit evaluation, and the second one is the indirect benefit evaluation. The procedures is relatively same. For the direct, we just ask the fishermen for the detailed information. I told you before that. So for the indirect one, we just go to the fish market, maybe the company, try to, for example, we will ask the price of the products, commercial products, for its whether it's used, whether it could be useful and some beneficial to the sea area, water environment conditions, yeah, something like that. And then we will conduct the input and output analysis evaluations, like the third subsection showed. Okay, so in the second subsection, we have a lot of impact evaluation. So the first one called cognitive impact, and the second one is the industrial impact, and last one is the employment impact. We should consider all about this and try to make a comprehensive survey and evaluation of the construction of artificial reefs. And finally, I'm going to show you the report writing, because after we collect samples and try to analyze them, we should come into being a report writing, write a report, right? So in the first one, we should write a report according to the following procedures. So the main content should be will consist of the 4 sections. The first one, the construction status of artificial reefs, and the second one is the survey activities. And then we try to analyze the data set we collect from the actual area, and then try to analyze it and try to make a result according to the effect evaluation. And then we will, these are the requirements we would like to do during the writing work. So please have a look. We should obey the timeline, and we should consider the explanation of the deviation. Yeah. Okay. After writing work, we have to do the archiving work. Yeah. So the procedure is a little bit same from the previous one. So constructive, the first one, construction survey and data analysis, and we get the result, and the final report we write the final report and the review and the acceptance. So these are the requirements, so please have a look. I'm not going into details. Okay, so that's all for today's sharing about the topic. Yes, thank you very much. Terima kasih.
Okay, thank you very much for Dr. Shigao for his wonderful sharing today. Okay, I know that some of you already have questions in mind, but before we're moving to the second presenter, I would do a quick translation about the summary of the information that shared by Dr. Xiekao. So, jadi pada dasarnya informasi yang tadi disampaikan oleh pemateri pertama itu adalah mengenai apa saja sebenarnya yang mereka sudah lakukan. Salah satunya itu adalah survei, termasuk survei ekologi, biologi, namun juga ada beberapa survei tambahan yaitu carbon sequestration dan microplastic survey, itu untuk memastikan bahwa artificial reefs yang merupakan salah satu program mereka itu secara efektivitas itu terbukti. Jadi ada survei yang mereka lakukan secara berkala, termasuk juga ada social economic survey yang tujuannya itu adalah memastikan artificial reefs ini secara fungsi ekosistem dan juga fungsi untuk social economic untuk masyarakat di sekitar itu tercapai. Kemudian yang tidak kalah penting itu adalah bukan cuma mengenai surveinya, tapi juga menganalisis dan akhirnya mereport yang akan dijadikan informasi bahwa program yang mereka lakukan itu tercapai targetnya, seperti itu. Okay, thank you very much once again for Dr. Xiekao. Now we are moving to our second presenter, Dr. Ning Chen. Is a lecturer at the College of Fisheries, Guangdong Ocean University. She received her PhD in Fishery Resources from Ocean University of China in 2022. From 2019 to 2021, she conducted joint doctoral research at the School of Marine Sciences, University of Maine, USA. And since 2016, Dr. Chen has been engaged in research on fisheries stock assessment, fisheries management, and marine ecological conservation, with particular interest in population dynamics, fisheries stock assessment, responses of fisheries resources to climate change. She also has published more than 10 academic papers and participated in 3 national research projects. She also took part in ICES stock reviews in 2019, 2020, and 2022, gaining international experience in fisheries stock assessment and management. To Dr. Ning Chen, please.
Good morning, everyone. Actually, it's my 7th time to be in Makassar. I cannot count the true numbers. Maybe 8, maybe 9. So many times. Now I'm very familiar to Makassar. I know where can I find the good coffee, where can I find the Chinese food maybe. So I'm also very pleasure to be here to share my presentation today. So the topic of my today's presentation is international fisheries development and management under global change. Which way? Can I use this? Okay. As we all know, international fishery development cannot be discussed separately from the broader ecological context. Climate change, habitat loss, over exploitation are jointly altering ecosystem structure, leading to biodiversity decline, reduced ecosystem resilience, and increasing tipping point risks. Especially for fisheries, these changes are reflected in stock distribution, great uncertainty in productivity, and growing livelihood pressure on coastal communities. Therefore, international fishery development can no longer be treated only as a production issue. It must be linked to ecosystem integrity, resources assessment, adaptive management, and regional cooperations. This slide just presents regional biodiversity trend from the 2024 Leveling Planet report. If you guys are interested about this report, you can search by yourselves. From this report, it showed that the Living Planet Index has declined in all regions, but the magnitude of decline varies greatly. For fisheries management, this regional variation is important because resource conditions, ecological pressure, and management capacities differ from place to place. Therefore, management strategy must be regionally adaptive. Global monitored wildlife population declined by an average 73% between 1970 and 2020. And by ecosystem type, freshwater species experienced the most severe decline, reaching 85%. Terrestrial species declined by nearly 70%, while marine biomass declined by more than half. So by geography pattern, Latin American and the Caribbean declined by 95%, and the Asia Pacific region by 60%, with strong unevenness across region. This data shows that biodiversity loss is accelerating across both ecosystems and regions, providing an important ecological background for the following discussion of fishery resources management. Here is a very important example. Hawksby, is an important nesting population in Australia, declined by 57 between 1990 and 2018. Although this area benefits from the marine reserve protection within the Great Barrier Reef, hawksby turtles are still threatened by habitat loss, climate change, harvesting, and entangled by the illegal fishing net. The second example is Chinook salmon, whose population declined by 88% from 1970 to 2022. Dams have blocked access to historical spawning habitats, and warming has further reduced access to cold water habitat. So these two cases show that even where protection existed, species may continue to decline under multiple interreacting pressures. Yeah, for coral reef habitat, here is also an example called parrotfish. It's a key functional group in coral reef ecosystem. By grazing on algae, parrotfish help maintain the balance between corals and algae. When parrotfish are overfished, algae can overgrow and compete with corals for space, light, and nutrition. As a result, coral health and diversity decline, and many species that depend on coral reefs for habitat and food are also affected. So let us place biodiversity declines within a broad set of challenges facing human society. So global change and human development pressure are driving 5 major issues: climate change and global warming, rapid biodiversity loss, food security and energy security, environmental pollution and ecological degradation, and economic inequality and sustainable development. So these issues are not isolated from one another. For example, climate change can alter fishery resources distribution, biodiversity loss can weaken ecosystem service, and increasing demand for food and energy can intensify pressure on natural resources. Therefore, when discussing fisheries development, we need to place fisheries within the broad framework of human sustainability. Yeah, according to the risk of ecological tipping points, as we can see on the left of the slide, 3 key threatened factors are listed: habitat fragmentation, exploitative resource use, and climate disturbance. These pressures interact with each other, amplify ecosystem stress, and increase the risk of system instability. Several examples of ecological tipping points are shown as well as in this slide. For example, the reversal of the Amazon rainforest carbon sink function, the collapse of coral reef ecosystems, and the weakening of the Atlantic meridional overturning circulation. Once ecological thresholds are crossed, these changes may become irreversible. For fisheries, this means that management cannot focus not only on short-term catches, but must also consider ecosystem resilience and long-term risks. Yeah, we just starting from global change. We can see climate change, biodiversity loss, pollution, and habitat degradation. This pressure affects fisheries through stock redistribution, productivity shifts, and increasing uncertainty in stock assessments. At the same time, fisheries are also expected to support food security, employee income, as well as raising aquatic food demand. The strategic question is how can fisheries provide food and livelihood while staying within ecological limits? To answer this question, governance tools such as TAC, MSY, marine protected area, habitat restoration, and adaptive co-management become very necessary. Now we just move to the second session is about global fisheries overview. In our previous session, we saw that global ecosystems are undergoing profound changes. Here, we turn to fisheries themselves. In this part, including three contents, global capture, production, status of fishery resources, and changes in fishing fleet. Our data comes from SOFIA. SOFIA is FAO's biennial flagship report providing systematic analysis of fisheries and aquaculture trend and global and regional levels, as well as the assessment of the status of global fish stock. This figure just shows the changes in global fisheries and aquaculture production of aquatic animals from 1950 to 2024. Is the latest version of SOFIA. The overall trend is clear. Global aquatic animals production has continued to increase, and aquaculture has become an increasing important driver of this trend. Capture fisheries have become relatively stable after a certain period. And for the spatial pattern of marine capture fishery production, China has been the highest producer since the middle 1990s, accounting for 40.8% of the global total in 2024. And Indonesia is also a major producer within highly diversified catches, tend to exhibit more stable year-to-year production. So this is important for today's topic. China and Indonesia are not only major fishery countries, but also share common needs in nearshore resources conservation, capture fisheries management, ecological restoration, and coastal community development. Therefore, our marine ranching cooperation has a clear background in resources governance and practical significance. Yeah. According to the global trend in the status of marine fishery stocks from 1974 to 2023, in 1974, about 90% of assessed fish stock were classified as biologically sustainable, but by 2023, this proportion had declined to 62.4%. One important application is that larger and more productive stock tend to be better managed and more likely to remain sustainable, while small-scale, data-limited, or weakly managed fisheries are more vulnerable to risk. For the changes in the fishing fleet, after FAO improved its data collection and analytical method, major revisions were made to fishing fleet data for 1995 to 2022, especially for Indonesia. Yeah. after inland vessels were included, the fleet was estimated about 1.1 million vessels in 2022, making it the world's largest fishing fleet. Globally, fishing vessels were estimated about 4.9 million in 2022. For the future demand for the aquatic animal foods to maintain the 2022 per capita consumption level of 20.7 kilograms through 2050, global supply of aquatic animals food would need to increase by 36 million tons or 22%. Africa's current per capita consumption is only 9.4 kilogram. To reach the 2022 global average, its supply would need to rise by about 38 million tons. This shows that meeting future demand will require strategic planning, aquaculture expansion, improved capture fishery management, and upgraded value chain. So why does fishery management matter? Marine ecosystems are biologically rich and provide many ecosystem services, including food supply, water quality maintenance, tourism, and cultural values. However, overfishing, coastal development, pollution, and invasive alien species are causing declines in marine biodiversity. Fisheries management is important because it concerns not only fishery resources themselves, but also ecosystem health, coastal livelihood, and economic development. In other words, protecting fishery resources is not about restricting development. It is about ensuring that resources can continue to support human society in the long term. Yeah. More than 1 billion people depend on fishery as their primary protein, while around 75% of the world's fishery have reached or exceeded their productivity capacity. This means that fishery plays a critical role in food security, but also faces strong pressure from overexploitation. Now we move to the third section, fishery management strategy. In the previous section, we saw increasing global fishery production, declining stock sustainability, and growing uncertainty caused by global change. Under these challenges, traditional experience-based management is no longer sufficient. We need more systematic, scientific, and evaluable management strategies. Yeah, so firstly, we should to define fishery management. Fisheries management is a comprehensive process that includes information gathering, data analysis, planning, consultation, decision making, resources allocation, and the formulation and implementation of rules or regulations governing fish activities. This diagram on the right shows the function and the responsibilities of fishery management authorities. Yeah, and this flowchart summarizes 8 key principles of fisheries management. These principles can be grouped into 3 dimensions: resources and ecosystem basis, management, trade-off, and uncertainty, and governance and participation. First, fish stock and communities are finite, and biomass constraints potential yield. At the same time, stock biomass is affected by environmental changes. Second, human demand can conflict with resources stability. In multi-species fishery, it is impossible to maximize all yield simultaneously, and management is always subject to uncertainty. Third, fisheries management must consider social and economic priorities, access rights, and participatory co-management. Therefore, modern fishery management should be sustainable, precautionary, ecosystem-based, and participatory. In general, fisheries management objectives can be divided into 4 categories: biological, ecological, and economic, and social objectives. Here, I just want to introduce a very common used method for fisheries management. It's called MSE, Management Strategy Evaluation. MSE is a systematic approach that uses computer simulation to test the performance of different management strategies against the specific objectives. Now it was originally developed by the Scientific Committee of the International Whaling Commission in the 1980s to calculate potential catch limit for commercial whaling and actual catch limit for above-ground subsistence whaling. The key value of MSC is that it allows managers to compare the robustness of different management measures under uncertain future conditions. MSC has been applied in different countries and fisheries, as we can see in the slide. In USA, MSC was used to compare the management procedure, the performance of management procedure for marine mammals, and in South Africa, MSC was used to several single species fisheries, and as well as in Australia, scalefish and shark fishery was also used, managed by MSC. And also, there are many different committees use MSC to do the fisheries management. For example, the CCSBT, ICES, and STECF. Oh, sorry. There are 3 primary functions of MSC. The first is to formulate management strategy for a specific fishery, translating management objective into concrete rules and measures. The second is evaluating the effectiveness of management strategies. And the third one is evaluating the applicability of management strategies. Let's see some case study. In the formulation of management strategy, MSC can be used for benthic habitat management, broad fish community composition, bycatch of species with high conservation value, and food chain interaction and dependence. In the evaluation of management effectiveness, the rock lobster resource at Tristan Down Tsangha provide an example where a management procedure was selected to provide annual TAC recommendations and was further tested for robustness. In evaluation applicability, MSC helps determine whether a management procedure is suitable for a particular fishery and management context. Therefore, the strength of MSC lies in connecting ecosystems, resource assessment, and management decision making. Here is the framework of MSC. For data-rich fisheries, MSC usually include an operating model, data generation, data observation, estimation method, management strategy, harvest control rules, implementation models, and performance statistics. For data-limited fishery, as well as especially in China or some developing countries, the framework emphasizes limited data-limited stock assessment methods, management procedure, and input or output controls. Whether a fishery is data-rich or data-limited, the core logic of MSC is the same. An operating model is used to simulate the true stock and fishery dynamics. The management procedure makes decisions based on observed data, and performance indicators are then used to evaluate the management outcomes. Let me introduce a case study about the large yellow croaker in China. This species is one of China's 4 traditional major commercial marine fisheries. However, in the late 1980s, the fishery suffered a severe decline and even collapse due to excessive fishing pressure on spawning and overwintering aggregations. Since then, long-term and large-scale stock enhancement programs have been widely implemented along the eastern coast of China to restore the resources. However, the ecosystem impacts of these enhancement programs and the ecological carrying capacity for large yellow croaker remain insufficiently understood and assessed. Therefore, this case is well suited to illustrate how ecological models and an MSE framework can be used to evaluate the combined effects of stock assessment and management strategies. For this research, the author, based on data availability, 20 alternative management procedures were developed, including 5 input control and 7 output control. And an ecopath model of the main river estuary ecosystem was developed and used as operating model within an MSE framework. The model was used to assess the effects of different management procedures on the large yellow croaker fishery, estimate the ecological carrying capacity of large yellow croaker, and explore optimal management procedure. By setting threshold value for these indicators, satisfactory management procedure can be identified. This slide presents the performance of 12 candidate management procedure after a 20-year simulation. The results show clear trade-off among different management procedure, no single strategy dominance or objectives. Overall input control measures performed better than output control measures in maintaining biomass and preventing overfishing. And the study also analyzed the effects of different scenarios. This scenario design helps distinguish the effects of single measures and combined management measures in practice. Resources recovery relies depend on one measure alone. It's usually depend on the combined effects of effort control, fishing, moratorium policy, stock enhancement, and continual monitoring. So in previous slide, we focus on fisheries management strategy and the large yellow croaker case, showing how model and management procedure can be used to select more appropriate measures and stock resources pressure. Next, we just move to even more complex context, climate change. Climate change not only alters the marine environment, but also affects fish distribution, fish growth, natural mortality, habitat. Therefore, future fishery management can not only rely on historical stock conditions, it must also account for long-term climate change together. Yeah. Okay. Climate change poses challenges to fisheries management. It can cause a shift in fish populations, habitat alterations, and the trend of fish becoming smaller. As a result, existing management objectives may need to be revised. Developing countries, in particular, often lack sufficient information on climate responses and adaptation strategies, making management more difficult. Nevertheless, since science-based management can still make a significant difference, sustainable stock management, reduction of discard, increased consumption of species lower in the food chain, and the transition to sustainable agriculture can all help improve the situation. So are the effects of short-term climate fluctuations the same as those of long-term climate change? Short-term climate fluctuations often occur in cycles when environmental conditions return to normal. Fishing conditions and total landings may rebound. However, if climate change follows a steady and unidirectional trend, such as long-term warming, fishery system may not simply return to their previous state We need to understand the climate impacts on fishery from a long-term perspective rather than treating them only as a temporary fluctuations. Climate change affects fisheries through several oceanographic pathways, for example, ocean warming. Over the past 30 years, the upper ocean layer from 0 to 300 meters has been warming, which can alter fish habitat and distribution ranges. The second is sea level rise. Melting glacier and ice sheets affect coastal wetlands, estuaries, and nursery ground, as well as the ocean circulation, wind system, and the storms. These changes can alter nutrition transport and upwelling system and increasing the risk of extreme weather events. The fourth is salinity change. Warming and freshening of surface waters can alter stratification, while deeper salinity changes may affect the ecological process. Ocean acidification affects coral, clams, plankton, and other organisms that rely on stable chemical conditions to build structure, thereby influencing the foundation of marine food webs. Warmer water contains less oxygen, and the model predicts that global ocean oxygen level may decline by 1 to 7% by 2100. Yeah. Climate change is already affecting global fisheries and may cause significant changes in marine food webs and ecosystem, leading to declining productivity. Study indicated that for every 1 degree Celsius rise in temperature, global fishing potential may decrease by more than 3 million tons. Use anchovy and sardine as an example to show sensitivity of small pelagic fish to ocean environmental variability. Many of the world's largest marine fisheries are based on small pelagic fish such as anchovies and sardines. These species are often found in highly productive upwelling systems such as those of California, Peru, and Canary Island, and South Africa. When feeding and spawning conditions are favorable, their population can expand rapidly. However, when ocean conditions change, this population can also collapse quickly. This case shows that even high productive fishery may experience strong fluctuations under changing climate and ocean conditions. Yeah, here also two case study about the effects of climate change on fisheries. Climate change is driving a large-scale redistribution of global fishery potential. The general trend is that high latitude regions may experience an average increase of 30 to 70% in fisheries potentials, while tropical regions may experience declines of up to 40%. This directly affects social and economic development, especially in tropical regions and developing countries. Of Maine as an example, because the Gulf of Maine, the sea rising faster than in 99% of the world's oceans. Climate change has reduced recruitment and increased mortality in Atlantic cod population in this region, creating challenges for traditional management plans. This case shows that in rapidly changing environment, management based not only on historical catch data and static reference points may fail to reflect actual stock dynamics. Therefore, future resources management need to incorporate environmental indicators such as temperature, habitat change, and recruitment variability into assessment and decision maker. We now move to the fourth session, international cooperation. In the previous sections, we saw that global changes fishery pleasure, climate impacts, and management uncertainty are all increasing. Under this context, many problems have exceeded the capacity of any single country to manage alone. Marine resources are mobile ecosystem are connected, and fishery production and the market are linked regionally and globally. Therefore, international cooperation is not only diplomacy or academic exchange, it is also an essential tool for responding to global fisheries governance challenges. So, global change and biodiversity loss creates shared risks that no country can manage alone. International cooperation can turn scientific knowledge into restoration action, policy dialogue, capacity building, and network governance. There are four cooperation pathways. The first is field demonstration and restoration, including artificial reef stock enhancement and monitoring. The second is shared water resource governance, including joint surveys, species selection, and effect evaluation. The third is mechanism and the research platform. The fourth is network and capacity building, including visit, training, postgraduate exchange, and technology transfer. Overall, under global changes, international fishery cooperation must integrate demonstration, science, policy, dialogue, and talent development. Let me just share some case about China's cooperation between Silk Road countries. The first one is our project. I think everyone is very familiar to this project, Sino-Indonesia Nearshore Marine Ranching Cooperation. China and Indonesia have advanced this cooperation through institutions, including Guangdong Ocean University, Shanghai Ocean University, Hasanuddin University, and Shiakula University. The key feature of our cooperation is the integration of artificial reef stock enhancement and technical training. Artificial reef provide a basis for habitat restoration, stock assessment, enhancement, support targeted resource recovery, and technical training improves local management and absorption capacity. For the Q work package of this project, the first is artificial reef technology, focusing on reef design, site-specific deployment, and key habitat restoration, reflecting a restoration-first approach. The second is stock enhancement technology, covering species selection, ecological carrying capacity assessments, release planning, and effect checking, reflecting the requirements for science-based release. The third is talent development and technical training, like we do now, which aims to train graduate students and technical personnel and improve local management and technology absorption capacity. Together, these three work package from a complete train from ecological restoration to resource recovery, and then go to government capacity building. The next case is China-Vietnam Cooperative Resource Conservation in the Beibu Gulf. The Beibu Gulf is an important shared fishing area for China and Vietnam. So fishery cooperation there naturally has a transboundary governance dimension. The two sides use joint stock enhancement as an important tool for conserving shared marine resources. Since 1917, China and Vietnam have carried out 9 consecutive joint activities. In 2026, the scale of the joint release reached 270 million individuals, and monitoring results show that the recapture rate has remained above 5%. The focus here is not only the numerical scale, resources survey, species selection, release planning, and effective evaluation are themselves part of co-governance. In other words, when two countries repeatedly cooperate around the same resources in the same water, they gradually develop shared rules, shared responsibilities, and mutual trust. This is the process through which transboundary fisheries governance capacity is formed. Another case is about China-Pakistan maritime dialogue. Unlike the previous two cases, this project emphasizes mechanism-based cooperation. It is not a single project or a one-time activity. Instead, it creates a recurring dialogue platform where marine security, the marine economy, marine science, and the marine environment can be discussed together. Some official news releases show that by the fourth round in 2023, marine fisheries, marine science, search and rescue, disaster mitigation, and marine pollution control were already key cooperation topics. Another case is China-Sri Lanka Academic Forum on Tropical Marine Environmental Changes was jointly organized by the China-Sri Lanka Joint Laboratory and the CAS China-Sri Lanka Center. A key feature of this case is that research institutes, university, and governance agencies were brought into one cooperative setting. The fifth example is about China-Asia Belt and Road Joint Laboratory for Mariculture Technology. It's also supported by Shanghai Ocean University. This case highlights the value of platform-based cooperation. The real importance of a platform is not its label, but whether it can turn research capacity into a regional network and local applications. Examples include joint research and sharing, forum and graduate exchange, executive fishery training and technical service, and demonstration sites and technology transfer. For this forum on fisheries, agriculture, blue economy research, and academic cooperation was co-hosted by Ocean University of China and the Asian Fisheries Education Network, with a focus on strengthen China-Asia marine economic cooperation for global development. Yeah, it's all for my today's presentation. Thank you for your guys' attention.
Thank you very much for Dr. Ning Cheng for your comprehensive presentation about the fisheries management and the importance of international collaborations to maintain our fisheries resources sustainability. So before we moving to the last presenter, I will do a short a translation about your presentation to our students. Pada dasarnya yang disampaikan tadi adalah tekanan yang sedang dialami terhadap sumber daya perikanan kita, dan dari begitu banyaknya instrumen atau pendekatan pengelolaan sumber daya perikanan, maka ada yang disebut sebagai management strategy evaluation, yaitu untuk memastikan bahwa dari berbagai jenis atau berbagai pendekatan pengelolaan perikanan mana sebenarnya yang paling tepat untuk sumber daya perikanan tertentu. Kemudian tadi disampaikan juga bahwa pentingnya international collaboration itu untuk memastikan bahwa sumber daya perikanan yang merupakan source of protein atau sumber daya yang kita butuhkan untuk sehari-hari itu adalah tetap terjaga atau sustain gitu. Jadi tadi disampaikan berbagai macam sebenarnya bentuk kolaborasi yang dilakukan oleh China. Salah satunya ada China-Indonesia collaboration, kemudian ada juga China dengan Vietnam dan China juga dengan Pakistan, dan juga beberapa jenis inisiasi yang diinisiasikan oleh pemerintah China untuk berkolaborasi dengan berbagai macam baik bilateral atau multilateral seperti itu. Terima kasih. So thank you very much once again to Dr. Ning Chen for your comprehensive presentation today. So we are now moving to Xu Xia Chiang. Am I spell it correctly? Our last presenter today. So Xu Xia Chiang is a doctoral candidate in fishery resources at Shanghai Ocean University. His research focuses on non-contact in situ underwater observation technologies for fish, and he has participated in many marine surveys of high seas fishery resources, nuclear power plant cooling water index risks, and artificial reef marine ranches, and as well as the development and testing of AI, or artificial intelligence enabled biomimetic fish for underwater surveys. So please, Doctor.
Okay, thank you. Hello, everyone. I'm John. It's a great honor to be here and share our team's work with you. This is my first representation in English. Compared with the introductions of two teachers, as a student, my lecture may be more simpler. Please bear with me. Today, my topic is acoustic optical survey method for artificial reefs. Yes, my presentation has 5 parts. Artificial reefs can provide habitats for marine life. They help fish gather and improve local marine environments. In the past, many studies focused on reef shape, material, and layout. Now we also need to ask one important question. After the reefs are deployed, how well do they work? We need a scientific method to answer this question. Traditional fishery resource surveys often depend on catch data. This method is discrete, but it has limitations. It may disturb reef habitats. It may also be limited by management rules and field conditions. Therefore, we want to use non-destructive survey methods. Acoustic methods have a large detection range. They are useful for studying the spatial distribution of fish schools. Optical methods provide clear images. They help us see fish's body shape, behavior, and reef surface conditions. Each method has strengths and weaknesses. In this framework, we mainly use 4 types of equipment. The first is active sonar, such as the EK80. It detects fish schools over large areas. The second is an ROV, remote operation vehicle. It can work underwater instead of divers. The third is an underwater stereo camera. It can take images and estimate target size and distance. The fourth is a biomimetic fish. It moves quietly and causes less disturbance, so it is suitable for close observation. This is a common ROV. It has lights and a stereo camera and imaging sonar. The ROV moves underwater with propellers. We usually use it to observe the inner structure of reefs, organisms on reefs surface, and nearby fish activity. One problem is that the pipelet may stir up the seabed sediment. This can reduce imaging quality. The EK80 is a scientific echo sounder. It sends and receives sound waves to collect echoes from underwater targets. Different frequencies are suitable for different water depths and different targets. Before use, the system needs to be calibrated. The data needs to be processed in software. We want to obtain 4 types of key information. The first is morphological features, such as body length and body outline. The second is acoustic response features, such as target strength. The third is a spatial distribution. For example, where fish schools are more concentrated. The first is behavior. For example, how fish approach or leave reefs. Stereo cameras and sonar can provide these types of information. This is our first generation system. It can work at a depth of up to 300 meters. It also identifies several fish species in tests. After data conclusion, data processing is very important. Now, the system has reached its third generation. We are collecting more data at sea. In the future, we hope the system will be more stable and more intelligent. Beside EK80 data processing usually includes several steps. First, we remove blank and invalid data. Second, we set the survey area for calculation. Third, we remove noise. Common noise comes from waves, shapes, and non-target organization. Fourth, we integrated valid echoes. Finally, we can obtain the acoustic response of the target organisms and estimate biomass. In simple terms, this method helps us estimate how many organisms or how much biomass may be present in the area. Besides on previous studies for shrimp, different organisms have different target strengths. For large fish, it is about minus 50 dBs. Target strength can also be affected by frequency, body size, and swimming posture. So, these values are not fixed answers. The principle of a stereo camera is similar to the human eye. A single camera can only capture a two-dimensional image. It's so difficult to judge distance. Two cameras can observe the same target from different angles. We can calculate the position difference of the same point in the two images. The difference is called disparity. Besides on disparity and camera parameters, we can calculate target distance and size. With these methods, we can survey artificial reef areas. Next, I will show some results. These results can help you understand the role of the equipment. I will first introduce the EK80 survey results. This difference is called in marine surveys. We usually focus on two questions. First, how does biomass change over time? Second, how is biomass distributed in space? The index used here is NASC, which means natural area scattering coefficient. It may indicate more organisms in this area. This figure shows the trend of jellyfish. We carried out several surveys in spring. The results show that the acoustic response of jellyfish increased greatly in April. Then it gradually returned to a low level. This means the jellyfish may have a clear seasonal pattern in this sea area. This figure shows the trend for shrimp. Shrimp are small but abundant. So, biomass estimation is more difficult. If we use the number of individuals or total weight, the result may be unstable. Therefore, we standardized designed the data. This makes the result from different ratios easier to compare. This figure shows trend for small fish. Overall, the result shows the EPRA may be provided with stronger biological activity in this season area. It also gives us a useful reference from planning future surveys. Besides change algorithm, we also need to focus on special changes. The 5 stations in the figure respond to different locations. Before deploying artificial reefs, we can first survive the biological distribution at this location. It can help us choose better reef deployment areas. If we analyze space, months, and stations together, we can see clear distribution patterns. With the type of figure, we can judge which stations are more suitable for certain target organisms. It can also support site selection for artificial reefs. After reviews are placed on the seabed, we can use imaging sonar to check their states. Imaging sonar can work in the turbid water. It can show structural outlines more easily than a normal camera. We usually check whether the reefs have moved, whether they are damaged, and whether their distribution is reasonable. Optical cameras can provide more direct images. Here, we can see fish moving near the artificial reefs. Such video directly shows the reefs can provide habitat space for fish. We can also help us analyze how fish approach the reefs, stay near them, and leave them. The still real camera can also observe organisms attached to reef surface. We can identify the type of attached organisms. We can also estimate their coverage area. Over time, changes in attached organisms can show the development of reef ecological function. Our university has also developed an AI biomimetic fish. Compared with normal propellers, it is quieter and causes less disturbance to underwater organisms. In the future, we can use for patterns in special waters, close observation, and protection of high-value fish. In field operation at sea, we also try to use drones. Sometimes the other visuals enter our survival area. This may damage equipment caps. It may also affect operation safety. Drones can observe nearby vehicle from the air and remind them to keep a safe distance. At present, we have collected data from different types of equipment. In the future, we hope to upgrade from one observation point to many observation points. Several sonars, camera, and smart devices can work at the same time. With artificial intelligent algorithms, we can build a more completed underwater biological database. In this way, artificial reef management will become more intelligent and more detailed. Finally, I would like to briefly show the biomimetic fish developed by our university. Please play the video for us. Yes. Different biomimetic fish have different swimming styles. They are also suitable for different tasks. Can I play the video? Yes, some are suitable for pipeline inspection. Some are suitable for high-speed movement. Some are suitable for crane sonars are another. Our goal is to use these new devices to better protect marine ecosystems and improve fishery management. Unfortunately, because of logistics issues, we cannot demonstrate the equipment on set this time. We hope we can bring a more complete demonstration next time. This is the end of my presentation. Thank you very much.
Okay, thank you very much for Su Chiang for your comprehensive presentation on the technology that can be used during the surveys. Before we're moving to the discussion session, I will do again a short summary of the presentation of our third presenter. Jadi dari presentasi tadi itu menjelaskan bahwa artificial reefs yang sebenarnya mereka sedang kerjakan itu adalah sebuah struktur yang sangat-sangat kompleks sehingga membutuhkan teknologi yang relatif lebih memudahkan dalam proses monitoring atau surveinya, sehingga ada yang disebut atau diperkenalkan tadi sebuah aplikasi atau teknologi yang disebut Eco Sounder atau EKT80 atau EK80 yang kemudian dikombinasikan dengan sonar pencitraan dan kamera stereo. Tapi untuk pengaplikasian dari teknologi ini sebenarnya masih banyak atau masih butuh beberapa pengembangan dan bantuan dari artificial intelligence sehingga aplikasinya itu bisa dilakukan secara paralel di beberapa tempat dalam waktu bersamaan untuk mendapatkan data yang lebih lebih lengkap seperti itu. Okay, once again, thank you very much for Su Chiang for your presentation. Now we are moving to discussion session. So for those participants who have questions for the three presenters today, please raise your hand, and I will do also check in the Zoom if any questions directed to our presenters here to the Zoom. Oh, not yet in the Zoom. Maybe in this class, anyone? Maybe we can first to our professor here, Professor Nita. Tolong. Okay.
Sorry, I'm late to come because there is some business have to finish. But it's very interesting. I didn't follow your presentation for the second presenter. I really want to ask a question. So yes, is there any challenge when you have to choose the strategy for the strategy for the management?
Okay.
This for your question, and then for the last one, it's very interesting topic. Good luck. It's very good research. I just wondering, you use the sonar, right? Do you have any particular what you call a sensor to differentiate between fish or live organism and then non-living organism in when you detect the sonar in from your artificial reef? Okay, thank you.
Do you want to answer it directly or?
So So maybe I answer the question. Yeah, the question is the challenge for choose strategy for management. Actually, it depends on data availability. For example, if we can collect such as cache date or some CPU date, you can choose. You can use some output control strategy, like you can cut the current cache to 7%, or cut the current CPU effort, fetching effort to 7%, and then you just using the new strategy to the MSE framework, and the MSE framework can help you to simulate what happened if we use the new strategy and compare the original strategy, and we can see the difference or the efficiency of the new strategy you set. And it can also depend on the strategy we already have. For example, in China, the fishing activity is limited in several months from March to October. It's a policy in China. We cannot fish in that 4 months. Yeah, so you also can set these policies as a strategy into management strategy evaluation framework. Yeah, like this one. Yeah. I know also in Indonesia, there also a policy. The fisherman cannot go to fish during the prey day, Friday, yeah, because we need a prey, yeah, so it cannot go fish in that days. So it's also a fishing management strategy. Yeah, thank you.
Okay, it's my turn now. Thank you for your questions. We also observe the fish depend on different sea area. For example, if we do some surveys in China, we also use EK80 sounders and imagery sonars because the water is more a lot of sediment. Stereo camera cannot also picture the fish clear, but in Indonesia we want to choose the stereo camera to photography different fishes and organisms. It's more clear and easier to get our surveys.
Okay. Also, you mean that the sonar for the surface, you prefer to use the camera rather than the sonar, right?
Yes, yes. We will use the sonar to locate where the fish is, and then we use the stereo camera. Thank you.
Okay, thank you. And any questions? I think in the back from the students, yeah.
Terima kasih atas kesempatannya. Jadi I want to ask to Dr. Shikego. You explained earlier that to monitor artificial coral reefs, you have to take data or water samples from the sea surface and from the top of the seabeds. So is it mandatory to do both, or we can just take one sample? And what is the impact of only taking one sample? Thank you.
I'm sorry, your question is only take one sample from where?
For example, if we only take from the sea surface.
Sea surface. Of course, we will simultaneously consider both the surface and the bottom. Regarding the water and sediment, of course.
Enggak, kalau misal enggak diambil sampel yang di atas bawahnya, hanya di atas.
She's asking if one of the research only want to take the surface sample, not in other environment, not in the seabed. So is it
Is it okay, or we can?
No, I think we should conduct the survey simultaneously regarding the water, sediment, and organisms. They should conduct together. We couldn't consider what just one sampling site. Yeah, it's according to the actual situation of that sea area. Thank you for your question.
Thank you, maybe. Lutfi.
Okay, my name is Shahram Fida and I am a undergraduate student from Marinstein Hasanuddin University. And first of all, I would like to thanks for the all speaker today. And my question is for the first speaker. And yep, in your presentation, you explained that the success of artificial reef is evaluated using various indicators, such as environmental quality, fish communities, benthic organism, and socioeconomic aspect. Based on your experience, which of these indicators is the more sensitive or provides the earliest evidence that an artificial reef is functioning successfully as a habitat, even before a significant increase in the fish community is observed? Thank you.
Okay, thank you for your question. So what I mean is to know about which survey is most important to the effectiveness evaluation of artificial reefs. So I think both of them are important. We cannot lack of one of the surveys. So,
Which one is sensitive?
since
Sensitive.
okay, if you mean the most sensitive one, I think the social-economic assessment is the most sensitive one because we have to encounter many people, a lot of people from the fish market, from the company and the pruner. So I think that is the most sensitive one. But for the previous water quality survey and fishery resources survey, we don't need to meet a lot of people. So that will like easy to go. Yeah. Thank you.
Thank you.
Any other questions? Yeah.
All right. Thank you for the opportunity. First, my name is Asma, and I want to ask a question to Dr. Shikagao. Earlier, you explained about environmental DNA. My question is, how can environmental DNA be integrated into environmental monitoring system? And is there a base indicator that can be used to assess the ecosystem health by doing the DNA informant?
Is that a question considering the environmental DNA cooperating, how they incorporate in the basic survey? Is that a question?
Yes, and I mean, is there also a indicator that can be used after doing the DNA monitoring?
Yes, of course, we should combine the environmental DNA as an environment-friendly technology with the previous basic survey investigation, like fishery resources survey. So, you know, the fishery resources survey is used to know about the information of a species, number of species and abundance, but that is not friendly, right? So, as a complementary method, the environmental DNA The appearance of it is to make a supplement for the fishery resources. I think they should become complementary with each other. Environmental indicators to evaluate environmental DNA?
It's actually the same question. Like,
Okay.
yeah, because first I asked how can it be integrated into the environmental
Yeah.
monitoring, and then is there an indicator? Because like the water system monitoring, there is an indicator whether the water is healthy or not, and I'm asking about the DNA monitoring. Is there an indicator to be to use?
Yes, of course. So in the first place, we should know the healthy status of the sea area and make a comprehensive assessment of the healthy condition. And then we will consider the environmental DNA survey afterwards. Yes.
Any other questions from students? Otherwise, I will use a privilege of moderator to give a question to. Dr. Ning Chen, I have actually questions because none of the students have a question yet. So I will use my privilege as a moderator to ask you a question. So I was wondering because you shared about how vast the information that is needed to do the evaluation of management strategy. I was wondering in China, what are the lessons learned that maybe we can use to do the to collect all of the informations needed for the evaluation, because in Indonesia we have, well, the government have a close partnership with universities, but also the government also has its own research institute. So it's the data is scattered. It's scattered, like government do the evaluation themselves and universities and NGOs also do it. So it's a challenge in Indonesia to make solid collaborations in terms of collecting all of the various data to do the evaluations. How about China? Do you have the similar challenge, and maybe to what extent China has, to form some of solution to those challenges?
Actually, we have same challenges in China. The data collected by government or collected by, for example, Shanghai Ocean University, it cannot be shared with Guangdong Ocean University. So it's the same challenges. And for MSE, as I showed in my slides, there are different framework for data-rich species and data-limited species. So for that scenarios, so challenges we have, maybe we can construct a data-limited framework about MSE. That only need some cache data, CPU data. In China, we can download from China yearly statistical book every year. It's published by government, and everyone can download by ourselves. It's free, and it's open. The data, the cache data, and yeah, by the government, it will publish the statistical yearly statistical book, and we can collect data from that book, and as well as we can also download data from SL website for software. As I also showed in my slide, every 2 years, FL will published the Sophia report, yeah. And there are also some data we can use. And for for some environmental data, I think we can also download on the website. For example, IPCC for the climate index date. And in NOAA, we can also download some species long-term catch or age structure date from the NOAA for single species. And it's also, we just try our best to collect enough data. So we call it best available data. And then we just put this best available data to the MSE framework. If you said how to deal with the challenge, I think we can do nothing because if the government they don't want to share if some scientific institutions they don't want to share the data, we cannot deal with this problem. We only maybe ask them, can you share the data for me? Or maybe we just give some suggestions for government. Yeah, we need that all the scientific institution or the university or the government to share the data that they collected, because it's very expensive. Every time they go to a survey, it's very expensive. So many institutions they don't want to share the data for others. And we also have another method to get data. It's I mean, maybe for Indonesia, I know many people do stock assessment or maybe manage fisheries management, and they already published the paper, they already published. And then you can use that data. For example, if some professor, they focus on fishery stock assessment on tuna, and they already published a lot of paper, and they already have some biological parameters. You can also use that data if you also focus on the tuna. Is that clear for you? Yeah, thank you very much.
So actually, China and Indonesia apparently have the same challenges, and the way of our government tackling the problem is quite similar as well to Indonesia. So maybe other questions in the back? Oh.
Question for Dr. Ning Cheng. So my question is, what are the main barriers to implementing climate adaptive fisheries management in developing countries? What are the main barriers to implementing climate adaptive fisheries management in developing countries?
Barrier
to implementing like
implementing what?
Yeah, like challenges of any difficulties that you have been
Oh, you mean the different challenges in different culture?
In implementing a climate adaptive
In implementing
fisheries,
climate
adaptive fisheries in
adaptive fisheries.
management in the developing countries,
Actually, I'm not very clear about your question. Maybe I just try my best to answer. Okay. Actually, for climate change, there are many climate index like AMO, PDO. Do you know that? And for that climate index, you can download from the website. And then we just apply that climate index to our China in our coastal fisheries. For example, if we have a target species like large yellow croaker, I already show you guys. And for example, the recruitment for this large yellow croaker, it will change because of the climate change. And there will be a relationship between the climate index and the relationship of recruitment of large yellow croaker. And you can add this climate index to that formulation, how to calculate the recruitment relationship between large yellow croaker. And then the recruitment relationship of that species will be changed along with the climate index. And after that, when we consider the fisheries management, we already considered the climate change. Is that clear?
Yeah, that's fine.
Okay.
Thank you. Thank you so much.
Hello, 我的名字是安迪苏基斯拉维尼和塞因，你可以叫我真顺心。So I have a question for Dr. Shikagao. So we know that we have been a lot of projects between Indonesia and China. I wanted to know so far which water quality that serves as the most sensitive parameters to the early warning for the marine terrain technology. And for the initial, especially for the initial implementations. And can you explain why and how important of the water quality is? And then I want to asking about for Dr. Ning Chen and Dr. N. Sushia Chiang. Considering about the project about Indonesia and China and also another country, between China and Pakistan, China and another country, I wanted to know the challenges between all of the country, because we know that the need of the people, we know that the adaptive local needs, it's very different between all of the countries. So I wanted to know what's the what is the challenges and also the adaptive for the IoT or the AI if we implement to these countries. Can you get it? What are my questions is?
The third question, the last question is
For the
yeah, I know. Can you repeat it again?
Yeah, you explained before that China and another countries have projects for the marine racing technology, right? And then I wanted to know what's the challenges between all of the countries, because different countries have a different challenges also.
I know the second question. I mean the last question.
Last question for the session.
Yeah. Can you repeat it again for?
Oh, okay. I wanted to know if we implemented the IoT or AI to those countries, what's the challenges? Because we know that different countries we have different challenges, right? So I wanted to know, because they have local needs, right? The local needs that's different environment, government,
the
and
challenges
etc.
when
Yes.
we use
IoT, AI,
yeah.
something like that. Okay, thank you.
Okay, thank you for your question. So you mean the most sensitive indicator during the environmental survey, right?
Yeah.
I think during, according to our previous survey, we found a really interesting phenomenon that the chemical oxygen demand, the value of it is very higher. So when we write the paper, we should be very cautious about these indicators, because one of our students, they sent the manuscript submitted to and received the reviewer's response, and reviewer said the COD is quite important, and why the value is so high in the target area like a coral reef, artificial reef areas. So we mean when we analyze the environmental parameters, especially the chemical oxygen demand and the biological oxygen demand for 5 days, we should be very cautious about this. If necessary, we can remove such parameters instead. So yes, that's my answer to you. Is that clear? COD and BOD.
COD and BOD.
Yes.
Okay.
Yeah.
Thank you.
Okay, according to the challenges between in the cooperation between different countries, I think the first is about the different laws management system in different country. For example, I already mentioned in China there are some limitation period in every year fishermen cannot go fish, and in Indonesia in every Friday maybe fishermen are also limited to go fish because of the prey activity. So in different countries there will be different laws and management system, so it can be a first challenge. And the next is about the economic level. If, for example, for some developing country like China, we may focus more on investment, fishermen's investment. But for some developed country, maybe they will focus more on marine conservation. So the aim are different because of different countries have different economic level, and I think it's the second challenge. And another challenge is our host already mentioned is data sharing. In our country, there are so many different scientific institutions, and the data cannot be shared between each other, depend on maybe some economical problems. So in different countries, we also have such problems. For example, we now have some cooperation between China and Indonesia, but the data cannot be shared if we don't have the permission of the government. So it's also a very big challenge we need to deal with. Thank you. Yeah.
Yeah, that's clear. Thank you.
Okay, thank you for your question to me. It is true that the technology levels of different countries vary. For instance, researchers in our country treat AI as a tool. The most challenging part is that you need to learn how to understand the problem to be solved and then make reasonable use of it. I think for students, the fast way is to first observe how people use AI on the internet and then implement it. Thank you.
Okay, thank you so much for the explanation.
Thank you very much. Do we have other questions? I think our participants are now have a clear and comprehensive understanding towards the presentation of our three extraordinary presenters today. So give a round of applause once again to Dr. Shika Kao, Dr. Ning Chen, and Sushi Chang for their time, expertise, and vision today to us. Thank you so much for our presenters and also to our participants for the for your active participation through the discussion session. Apa? Oh, now we're moving to the certificate hand to our participants who were asking questions to our presenters today. Widya, udah tunjuk. Apa sih? Tadi bilangnya langsung tutup. Untuk siapa, Bu? Sertifikat untuk? Oh, so the certificate is for the students. Diberikan oleh? Oh, so the three of you will be giving the certificate to our students.
Everyone?
Just to those who are asking questions. Yeah, yeah. Yang tadi kasih pertanyaan. Yes. There.
Dr. Sinyang.
Sinyang.
Let's see.
No. Ano
Ji, nanya.
Halo semua adik-adik, kalian lihat sertifikatnya itu dalam bahasa China ya. Jadi di bagian atas itu bisa kalian isi dengan nama, terus yang Chinese itu bisa kalian isi dengan tanggal. Ya, tanggal kegiatan berarti tanggal 23 June 2026. Begitupun juga yang in English di bawah. Ya. Silakan diisi. Lalu kemudian pengumuman, kita sudah siapkan makan siang, tapi ada kendala sedikit di jalan, jadi mohon ditunggu di sini saja ya. Oke, thank you. Bagi yang belum isi absen, presensi, tolong presensinya di belakang.
Sudah, nyala. Prof. Bilin Liu and all Chinese China team will be wait here for the lunch because the lunch box is a little bit late to arrive here, and yeah, we will be having lunch here, and then we will go to the rector's office at 1:30 or 1:45. 1:45. Okay. Yeah, please wait here for the lunch.
Bukan tak kunci. Gimana cara aku mengajar kalau begini?
Dari mana Bu Wit? Oke Ji. Terima jasa moderator.
Selesai itu?
Sudah. Tunggu makannya.
Udah dipahami, suruh absen.
Oh iya tuh. Pantas ada datang.
Baru tiba-tiba datang. Sudah juga bilangin di sini. Anda kayaknya baru datang. Buka TV. ikan ini. Ya, bisa jika orang tidak tahu. Kak, tambahkan mak sini 100 km persegi. Nggak tahu jutaan. Nah, nggak tahu jutaan-jutaan ini. 100 km persegi. Nggak tahu jutaan. Hanya hapus sedikit. Hah? Kasih lagi nih Pak, buat tambah sih 100 km persegi. Nggak tahu nih. Baru datang.
Baru makan?
Baru datang. Semoga itu ya.
But you can also take picture with us. Do you? Can we share one slide
Habisnya?
Oh, Iqbal ubah dalam bentuk PDF dah. PDF. Slide-nya.
Oh, oke. Just PowerPoint.
PDF, just PDF.
Terus, tunggu enggak? Mau foto sama Chinese.
Oh sudah diatur. Jadi kita nggak perlu balik sini.